375. And do you guys see how we get different values there? So the issue is that we should get the same values. But they don't really give you enough information to find a good constant of proportionality. So you end up with two different answers. So this is a problem with this problem. And then it says, how can the current be expressed as a function of resistance? So in part C, so current is this I. So what we can do is we can resolve the function for I. We have V equals IR. And what we want to do is we want to isolate I and then have R on the opposite side of the equal sign. So what can we do to isolate I? Roxy, was Roxy here? I don't believe so. Kevin, can you tell me what we can do to isolate I?
Can I say it?
Well, I want Heaven to say it, please.
Can't you like divide it or something?
Yeah, divide what?
To isolate I, divide
Yeah.
R?
Yeah, good. So we're trying to get R out of there. So if we divide by R, then we get I equals V over R. I just flipped the direction of the equation. Okay. This voltage is supposed to be a constant. But they didn't really give us enough information to be able to actually find that constant correctly because we got two different ones up here. So
Can you move the paper up, please?
I'm sorry, yes. Is that better? So that problem is pretty messed up, but there is information that we can pull out of each piece to get something down. So if you had anything like this in your work that you submitted, or if you go back and resubmit the work, just make sure you have something written down and you try to reason through the parts. So that was number 5. What questions do you guys have on what we did? Okay, if there are no questions, I'm going to go ahead and move on to number 6. I will scan this paper and post it on today's activity 2 so that you guys can go back and reference it. So if you didn't quite get everything copied down, don't worry, it will be posted. So I'm going to go ahead and flip the page, okay? All right, so the next question that was asked about was number 6. Number 6 says, on a certain map, 25 kilometers are represented by 2 centimeters. If 2 cities are 7 centimeters apart on the map, what is their actual distance apart? Okay, so maybe we have city A and city B. And so on the map, this distance right here is 7 centimeters. They're asking us to figure out what the actual distance between city A and city B is. So let's see. Betsy, are you here? Destiny, can you help me set up an equation for this? How would we set up an equation to find that missing variable? Destiny?
I was trying to figure it out.
Okay.
25. No, 2 over 25.
Yeah, either way works. We could have 25 kilometers over 2 centimeters, as long as this top part on the right-hand side is in kilometers and the bottom part is in centimeters. So do we know the top part?
No.
No. So that's going to be our X. And what's the bottom part going to be?
7.
Perfect. Thank you very much, Justin. So now we need to solve this equation. Jerome, can you help me solve this equation, please?
Don't you cross multiply?
Yeah, that's perfect. So we can cross
So-
multiply.
It would be 25 times 7.
And what is 25 times 7?
175.
Yeah. 175.
Beautiful. Perfect. And then we have one more step. Eddie, can you tell me what the last step to solving this equation is?
Divide by 2.
Perfect. Divide both sides by 2. And what do we get when we take 175 and divide it by 2?
87.5.
Would 87.5? Sounds about right. Okay. And this would be in kilometers. So city A and city B are 87.5 kilometers apart. What questions do you guys have about part A for number 6? No questions? Okay, so part B says, how can the actual distance be expressed as a function of the distance on the map? So now we're coming up with a general function that describes this whole thing. So we want, how can the actual distance, so I'm gonna label this as A for actual distance. So A, actual distance. And I'm going to have M as my distance on the map. Oops. Okay, so we're taking A and we want that to be expressed as a function of distance. So A needs to be isolated and then M needs to be on the other side of the map. So how can we figure out this relationship? Because they're not equal to each other, right? 25 kilometers is not really 25 kilometers on the map because that would be a ridiculous map and a not very useful map, right? So how do we figure out that constant that needs to be there? Shayla? Okay, Delamar. Delamar, are you still having issues with your microphone? Can you type in the comment box? So Delamar, if you're having issues with the microphone, you need to type in the comment box so I know that you're at least there for the chat. Let's see, it looks like there are 2 things. Okay, so Delamar, you need to type in the chat and let me know you're here and you can hear me at least. I'm gonna call on somebody else, Ayana, in the meantime.
Ms. Roberts, I'm gonna be honest with you. I don't remember how to do this.
Okay, well, try your best with me. We need to figure out, so we're able to figure out when we have 20, they gave us that when we have 25 kilometers, we have 2 centimeters. And we were able to figure out that 87.5 kilometers gave us 7 centimeters. So M represents our number of centimeters on the map. That's the map. So if we had 1 centimeter, what will we need to multiply that 1 centimeter by to get our actual distance?
You going in and out, what you say?
So basically we have a setup to find that proportion up here. Okay, because we know that 25 kilometers is the same thing as 2 centimeters. So
Right.
how can we figure out how many kilometers is 1 centimeter on the map?
Isn't it
Okay,
12.5?
Well, how do we figure that out?
You divide.
Divide
Oh.
what?
Yeah.
I divided 25
25 by 2.
by 2.
Yeah. So you can either do this or you can use the other proportion too. You could do 87.5 kilometers over 7 centimeters, and you should get the same thing. So what did you guys say you got?
12.5.
Perfect. So 12.5 is going to be our conversion factor. So when for every 1 centimeter we put in here, we multiply it by 12.5 to get the actual distance. So 12.5. And then this, sorry, I didn't do this well. Times M should
Can you
be
move your paper,
our
please?
equation that we come up with. Yana, does that help a little bit?
I understand it better now.
Okay, great. So all you're doing when you're trying to figure out this number, you're trying to figure out how many of these things is the same as one of these things, whatever it may be. Okay, so that's number 5 and 6 from the homework from last week. What questions do you guys have about number 6 now that we've completed that problem?